Good evening, class. Tonight we're going to discuss how to make, what's this one called? 5 of 24. Now that I remember its name. 5 of 24 is an interesting drawing. It's this dude right here. What's different about this guy from a previous one that you've already done, for example, 1 of 24. 1 of 24, when you guys did this one, had a rib in it, but that rib was flat. See that? It had a flat rib. And so therefore it had to cut, it had a curved back when you cut the back out. And it had a front that jutted out a bit. This guy is not the same. This particular one actually has a curved front and a curved back. The only reason you can tell that even it has that, meaning that the rib is not flat, is because of the fact that it marries beautifully to this curved feature right here. The bullnose end of this part, this bullnose end, whatever you want to call it, this curved end, the rib marries with it perfectly. The only way that happens is if it's tangent. The only way it's tangent is that it itself is also curved, following the same curvature of the whole shape. So because of that, you need to learn, how do I make a rib that follows a curve? That's the big question. How do I build something like that using a product, any product, in this case Solidworks? So our first order of business is to go ahead and start Solidworks. We're using, let me scooch that out a little bit, Solidworks 2018 is what we're using. They call it 2018-19 in academia land. So here it goes. File new. The default is inches, because that's with the last drawing we did earlier tonight was in inches. This is a part file. I hit OK. It opens up my drawing. I know I'm in inches because in the lower right corner of my SolidWorks screen, it shows IPS as my units. Remember that? If you ever want to double check yourself. First thing I want to do is turn my planes on, so I go ahead and turn them on. I also like turning on the origin so I can see that. Everything is visible. Okay? Next, I've got this shape. So the front view, always remembering to respect the cube, which I'm drawing out rather roughly over here because I'm using my mouse to do this versus a pen. That's an R. That's an attempt at an R. And that's the top view. So this is the front of the object right here. And if I outline my basic shape, I have a shape that kind of looks like this. Okay? That crazy blue thing I just drew, which represents this geometry that I'm highlighting now. That's what we're looking to create first. There's no reason, although somebody might say, well, why don't we just stack a bunch of cylinders on top of each other? We can, but that's too much work. And your teacher's lazy, and I would like you to be as lazy as me. So we're going to try to teach you a method that's going to get to end game faster with, of course, features in mind. Meaning, your basic shape, that entire outline, is what will revolve first, but when it comes to any holds, those are done separately, which means I'm not including this feature down here, this hole, this gap over here. We're not going to account for it when we make this object in the basic sketch. We're building the whole thing without a holds in mind. Okay? So when we jump over here and I go into sketch mode from the front plane and I build this shape, I'm going to be kind of rough in how I build it. I'm just going to draw some basic geometry without a lot of concern. I'm not even going to try to do that. I'm going to try to draw a circle to touch this, so it's tangent. See that? But I just drew a circle. I wasn't really careful in how I drew that circle, you notice? Then I'm just going to finish this other end off, and then I'm going to close it. Okay? Then I'm going to go ahead and trim using trim to closest, my preferred trim option, so that I have literally a basic shape. You're going to notice that I did stop this object in the back, but 1 second. Let me go to isometric real quick. By the way, I do not like this cube. That is one thing. It can go away. There we go. See how I've got the shape in here? I can go ahead and, I keep picking circle, sorry. I can go ahead and draw a straight line in here, at least to that point, and draw another circle here, so that way that's the interior arc. When I trim this off, and trim that element off, there's your basic shape. Now, that basic shape is not dimensioned in any way, shape, or form. So, having done these drawings before, and I want to make sure I get diameter. So if I go from here to here, am I going to get diameter? I get radius. What's my problem? I need a center line. That's correct. So I need to draw a center line. I can draw it through the whole part or any element of it. It doesn't matter. But when I draw a center line and I select it, now I do get diameter as my choice. See that? That only occurs because I have a center line in there. Please remember that reality. What is that outside diameter? 5. Okay? Oof, it got tiny. Now, it may not have been a good idea for me to do that. See, 9.75 is pretty big. It's about twice the size that I need it to be. So it probably would have been a better idea that I not start with the outermost shape, because as you can tell, it looks like I made it too big. So if I start with the inner shape, now I might get something. What's the inner shape?
2.14. No.
Well, that's what it says. You're right. But when I look at what I need, do I need an inner diameter? What do I really need? I need a radius, don't I? I need this identified. So this radius needs to be 1. And this outer radius needs to be 1.375. Yep. That's good. Yeah. So now let's see what dimensions I need. I can go from this wall to this element. Now what's this? What's the diameter? That's 3.14. Hey, pi. Somebody want pi? And from up here to, okay, it automatically saw diameter. Now we pick 5, and it's a little more reasonable. Now, obviously, this is too long. So what is that inner slice right there, this inner cut right here? That's 0.12. Yep, so let's do that. And then the next dimension, this guy, that's 0.5. And then, now we got this dude. See, I'm systematically just working from the back forward. Keep it simple. It's not a bad idea to do that. As this thing starts shortening up, then you'll get to your basic shape. Your basic geometry of up to 3. Now when I look at this guy in isometric, I'm missing something. The reason I say I'm missing something is because I have 2 elements that are still blue, and it says it's underdefined. This guy is not defined, so I got to identify that. So if I dimension this, that outer diameter is 1.25. See that right here? That's identified now. So what's this? Why is this? What's wrong with, ooh. Okay, the reason that's acting funny is these 2 objects are not tangent. Once I make them tangent, they take care of themselves. Now it says fully defined. Now I'm good to go. So it's all grayed in on the inside. That's telling you it's a pattern that it can work with. Now I go ahead and revolve. It automatically knows what to do. I hit OK. Done. Up to this point, you know what to do because you've done this before. This part of it's pretty straightforward. It's even not a big deal for you to just go to Hole Wizard. Now remember, with Hole Wizard, Do I pick the command first, then the face? Or should I pick the face first and then the command? Face first. Always face first. Make life painless for yourself. Okay? So if I look at this, that diameter through hole is there, 0.56. So 5/6, that's 5/8 of an inch. So if I just made it a standard hole, just a standard through hole, and looked for 5/8, 5/625, yeah, so that's a 5/8 hole. So if I find the 5/8 drill bit, I can show decimal values next to it. Is it 5/8? No, what did I do wrong? 5/8 is 625. What's 0.56? Good thing I did that, isn't it? It's probably a 9/16 hole.
Yeah, 9/16.
9/16, 0.5625. Got it? That's my mistake, 9/16. Okay? If it was 625, then it would have been a 0.63 hole. Remember that decimal, if I only showed it 2 decimal places? You're not going to find a 0.56 drill bit, but you are going to find a 9/16 drill bit, which is 0.5625, nominally. Okay? So that's why you're looking for a standard size. Then the next thing is position. So I want to drop it right there. Through all is fine because there's nothing behind it. There you go. See that? The keyway is the same way you did it for the other drawing when you remember doing the keyway for this wonderful drawing right here. Remember this guy? So the same process for this keyway. You use the same process for this other one. There's nothing else is new on here except the rib. The rib's the new conversation item. Okay, now there are some mathematical errors in here. These holes right here, they are 120 degrees apart from each other. Okay, so this dimension is wrong. I'll just throw that out at you, just so you know. So you're going to find some dimensions that are inaccurate. This particular drawing, if I looked at it in the right side view, does look sorry for the really bad sketch on the screen. Does look something like this. It's tough to draw this thing. It's a very crude drawing of what it looks like. But yeah, I know, don't laugh at me like that. But it's okay. I know, it's very bad. It's okay. But if I had to, it's like a person hands. Okay, fine. Then I'll make up images. What does that look like? Okay. But the idea is, it has that Mercedes-Benz look, whatever you want to think of it. You know, that's what I think. So it has that look to it. So when I'm over here, I'm trying to think, how am I going to build this? Well, you know, back to your teacher and her lazy habits. There is a rib down here. I'm not going to try to draw this rib over here, or the one that I can't see out here, because they're not in a normal plane position. I would intentionally pick the object that is at least lined up with a standard plane. That's the rib I would want to focus in on. So that when I go to the front plane and create my new sketch, that would be the place I want to be. Now, a few things to know. When I want to create anything on a round surface, I can't use my traditional convert entities approach to things that I would tell you to do normally. Instead, I would have you pick intersection curve. Anytime you deal with something that's actually round and I want to slice through it like an apple, to give you an example, you actually have to use intersection curve. You can't use convert entities. It doesn't work. Intersection curve, when I pick it, and I pick this plane, and I've got these elements, see that are here. Just pick those main body elements because that's where the rib exists. It exists, touches this thing, goes through this diameter of it, and then that ball, that front piece of it. When I hit OK, that's what I get. I get that outer perimeter when I use this feature. Now the other thing is, can I see into this object clearly under the current conditions? No. I always do recommend that you section view your object so that you could see into it. And that's what I just did. I clicked section view. Because I'm in the front plane, it naturally picked that plane, so it's pretty straightforward. Now I look inside of it and I see this inner shape. So I really have to convert that too. So I go to intersection curve, and now I'm going to pick those two inner elements and pick OK. So now I have both inner and outer elements selected. The inner cavity and the outer perimeter. Now, what I recommend as your third step is to highlight everything and turn everything, all of these crazy lines and arcs that the software generated, make them all for construction to make the next step easier on you. The reason I say this, I'm just telling you up front from experience, when you deal with a lot of odd-shaped objects, organic geometry, and you use this convert entities or convert, in the case of odd-shaped geometry, you're using intersection curve, those lines that it generates can actually fight you to make your sketch that you want to make. By turning everything into construction that allows you to use it, but it doesn't fight you to make your sketch. That's the reason I do that. It's just a tip, a word of advice from someone who's done this too many times. That's just my advice. So I say make everything construction. That way, nothing will fight you. So when I pick on an entity, if I double check if I check it out, it should be, unless I did something wrong. Yeah, it should all be for construction. When I touch them, it should all say for. That's perfect. That's what I want. Now I would make an actual real line from here, and of all things, I would drag it all the way into the part and touch that inner wall. And you know what? You could drag it all the way out here too. That's okay. See how I extend it way past the part? Okay. Then I'm going to take a line from this end point, and here's the weird thing. People wonder why I do this. I do this because I don't like carpal tunnel. I don't want my wrist to become my enemy in pain, all right? I'm not going to try to find the exact spot where this goes. I'm just going to put it out here. I did this with a different drawing with you guys when I was showing you how to make this guy. Remember this guy and I was saying finding tangencies? What a pain in the Badinsky they are? Don't! Let the computer do the job. That's what you got it for. When you have a high-end toy, like Solidworks and Banner, when you're using those high-end CAD toys, use them! Okay, don't revert to like you trying to do something and you can make the software do it for you. So in this case, I'm going to hold my control key down, pick my line, pick my arc, and pick tangent. Let it do the work. Okay? What's neat about that is I was close, but you see how the two lines don't touch? That's important. That means that if I trim this line back, okay, there is a point that these two meet, but you can tell that point is not at this curvature. It's inside the part. You can try to calc it out, which I wouldn't because I'm too lazy for that. I would draw my math equations out by literally drawing. I drew my vertical line, I've got my horizontal line, and when I trim the two back, that's it. That's the shape of my rib. You're going to ask me, well, okay, you've got this attached to this inside wall. Now I'm going to hit OK. You have this attached to the inside wall. Why? If I ever change that inside diameter, what's my rib going to do? Update with it. Yeah. Just like I proved before when I was doing the blade. Because the way the blade was drawn, when I change elements on the blade, it just expands and contracts and changes everything. Ditto for here. So now, I go to features and I go to extrude. I don't do revolve. And that's what people get confused. Well, it's supposed to follow the curvature of the object, so why would you extrude? And you're correct to question that. When I extrude this out, and I use the thickness of the rib, which is right here, the rib thickness, 0.375. 0.375. Make sure to merge results, by the way. Your results must merge. You must merge your results. We already experienced what happens if you don't in a previous project. Remember how it didn't work? So make sure to do this. Now, we don't want blind. We want mid-plane. We want it centered. And then we hit OK. It's still sliced, so you can't see what it did. So now I unsliced it. And now when I rotate it, you're going to see that a piece of it sticks out on each side, just as it did with the other drawing. The only difference is the other drawing had a flat top, and it was all right that it stuck out because it didn't matter. And just as it did with the other drawing, the other model we did, it also juts out down here. So nothing has changed. It physically behaved the same way. So how the heck do we make it curved? Well, my machinist in the room, do you have any solutions? Put it on a lathe and spin it, right? Is that what the two of you would like to tell me? Depending on the material. Right, now we start talking. Of course. We start getting into the material properties. If the radius isn't critical, you're going to sand it down, aren't you? Or a grinder or something. Right. But let's say the radius must be perfect. So now you got to put it on the lathe, make sure it's centered. Probably won't even start this way, right? You'd start with a whole different object. But anyways, so I see you're already thinking, what are the operations I have to go through to make it? In CAD, you can build anything. But in the real world, that's when we have to stop and think, how are we really going to build it? I agree with you. You'd have to stop and think through those operations. Here, I can just tell you, well, let's make a lathe tool on the fly, because we can. But here's the thing that we want to do before we finish this operation. What should I do first before I try to lathe this into a beautiful curve? What should I do next? Pattern it. Right. So instead of linear, I'm going to circular pattern this puppy. The features I'm patterning is the rib. No, the software is not intuitive. You have to intentionally know what you're picking. When you look to the left, there are all your options. Under direction, you have to actually identify the outer shape. You do want to identify how many you want, and I would recommend equally spaced. Or you can say instant spacing is 120. Of course, you could do that. That means the same thing as just saying equally spaced. Because 360 divided by 3 is 120. So the feature, you visually see what it's going to do. Make sure it looks good. I'm going to actually go to the front view. That looks right. Then go to the, not top view. Go to the right side view. Yep, that looks right. We hit OK. Done. Okay. Your holes are done the same way. You just drill a hole up here and then you pattern that around and you're all good to go. Next. So it's under linear pattern over here. It's all part of the features toolbar. Yeah, under the features toolbar, off to the right, after fillet is linear pattern. Underneath linear pattern is circular pattern, mirror, all the things that have to do with multiplying the component, the features that are on the part. So back to this guy. The thing that makes us unique is trying to create that rib. And this is when I say, in the last project, what did we do? We just needed to pop off these corners, right? So we created a circle in the back and did an extrude opposite of a normal extrude cut. We inverted the extrude cut. We used it as a cookie cutter to keep everything inside of it. Remember that? When we did that project. So in this project, we're not going to leave this flat. We actually want this rounded. So when I go to the front plane, the front view, and I pick on this plane and I create a new sketch, we're actually going to convert entities this outer edge. Now watch, you have to be careful. You want to make sure you pick the correct edge. It's this outer edge. Okay? Now if we pick this outer edge, we're not going to get the right thing. We can only pick that outer edge, and we hit OK. That outer edge represents the rib. It represents the rib at its tangency point with the arc. Do you hear the way I said that? That's what makes that position important. Now, if I just literally make an extended feature out here of who cares how far out. What does matter is you can't have it in, for obvious reasons. And you can't have it angled in any way, because that means your cutting tool is going to cut into this part the wrong way. It has to cut in straight, head on, like it would on a real lathe. That's the interesting part. For those of you that have done real lathe work, you know what I'm saying. The tool has to go in exactly in that position, otherwise the cut will dig into the part. So in this case, everything's aligned beautifully. You can't make a more pretty cut in the real world. It would be tough. So what you have built is a cutting tool that has the perfect angle to what you're trying to slice into. And now, when you go to features and you revolve, did I use the right revolve, guys?
No.
Nope. Inside Solidworks, remember, your added, like extrude, revolve, spline, sweep, not spline, sweep, loft, those, when you're adding those, they are separate and distinct functions from the subtract versions of them. Please remember that. So you have to pick the correct command. Many times I have a student who says, oh, I can't do that. It keeps adding material. I'm like, you keep picking the wrong one. You got to pick the other one. Oh, got it. Now, when I do a revolve, remember I need to have something to revolve around, an axis of revolution. So when you pick my my round body here, let's see if I could do this. I can't seem to find an axis. Okay, there's two ways to deal with this. One, you draw an axis as part of your sketch. Or two, remember your teacher's lazy. You go to View, Hide and Show, Temporary Axis. Got that? Again, I paused each time just so you go to the top, View, Hide and Show, Temporary Axis. If you turn that on, anywhere there's something round, an axis will appear. Got it? Gesundheit. Gesundheit. So now you can revolve and cut. Now look where the cutting tool is. It's right on that tangency point. Notice that? So I'm going to zoom back out. Revolve and cut. Okay, so now I'm going to pick my axis. See how it goes all the way around? See how it just swipes right there? Now, if you pay very close attention to that edge, when I click OK, it's gone. What remains is the line that represents where those two objects connect. Because anywhere there's a connection point, it does that. The softwares do that. But if you want to see what it really looks like, you change to shaded mode, and then you see that there is really no line there, because that's a pure tangency point. See that? And not only is a tangent up there, it's tangent down here. So you have no half moon, you have no weird connections like you did on the other drawing, because the other one was a flat surface connecting to a curved surface, and they were staying that way. That flat plane on this other drawing that you had done before, this guy, that stayed flat. That didn't change. That's why the back end had a little bit of a half moon in it, and the front end stuck out. just like it did here. The only difference is when we went and basically spun it and cleaned off those edges, you ended up with a curved surface. So it's tangent at the bottom and tangent at the top. I have to intentionally touch it so you can see that. See that? But together, if you just move the part around a little bit, see how it's beautiful? It just connects. It's purely tangent along that edge. It's tangent. If there was a shadow, you see how there's a shadow here? If there was any hint of a shadow, then it's not correct. Okay? This is correct because you see how this side wall is a shadow because it's a side wall. But it perfectly connects to this space. I don't see a shadow when I look at this angle. I don't see a shadow if I angle it this way. See? I can keep rotating it. See how it looks? It marries beautifully. That is a tangent, what do you call it? Rib attached to this object. Nothing like this other drawing, because this one is tangent right there. It's tangent to that front surface, and it's tangent to this back surface. And that's it. That's how you make that. And that's how you can do it all day long in any other part. Cool? That's how you make that item. The rest is just drawing what you normally have done, what you've already done to date. So if I change this to the wire, this is called with lines, I think they call it, shaded with edges. Even though this is a tangent edge, it still shows an edge. Just like this arc is tangent to this side wall, it still shows an edge. The edge of where it's tangent. It just does that. So that's how the software works. All of them do that. The last thing, not the last thing, I've added everything. You've got to add the keyway, cut the keyway out, and add the holes. That's all that's missing. And then this part is done. The biggest thing I want to show you tonight was that how to develop the ribs correctly for this part. And that ends this lecture.